So here we are going to work with this auto data set from Introduction to Statistical Learning. So we are going to split it into half training set and half validation set. So the total number of observations here is 392. So we're going to split it in 50-50, training and validation. So training and validation. So every time we're going to train our model on the training set, and then we're going to fit it to validate it to report the error on the testing. And we're going to do it with polynomials of degrees 1 to 12. So our response variable is miles per gallon. So this is my y. Our predictor is horsepower. So this is going to be my x. So I'm going to fit models that look like this: b0 plus b1 x. This is degree 1. Then I'm going to fit another model, same thing but plus b2 x squared. This is a model of degree 2. Then I'm going to fit the third model plus b3, same thing plus b3 x cubed, and so on, right? And I'm going to fit 12 models, so for degrees from 1 to 12. And as you see in this graph, so I have conducted 9 experiments like this. This, by the way, this is done in the textbook too. So I did the same thing, but by my own, right? So I did not insert figures from textbook into the lecture. I just, just to make sure that that we are doing it right and that there is no mistake here. I just rerun the whole experiment, the whole numerical experiment, and this is what I got. So for 9 different splits into training and validation sets, I plotted this curve. So how test error depends on the degree of the polynomial. So, and we noticed some common things. So when the polynomial is linear, so the error does not vary too much, right? When in all these 9 experiments, the error drops from when we continue fitting models. So, and the polynomial of degree 2 is much more accurate than the polynomial of degree 1. But then we have differences, right? So in particular, when we have our polynomial of degree 12, different models, they have a very different error. And I guess we can assume that there is overfitting here. But even if we try to see, I don't know, so for which of these experiments, so what is the degree that gives us the smallest test error? And we see that it's different. So say, for example, for this model, the best degree is 2. So it happens here. But say if we look at this model instead, then here the optimal degree is 11. Seems to be 11. Okay, so to be honest, it's not very clear, but at least, this whole part of this curve between 7 and 12 seems to produce more or less constant errors. So, which means that if we did this split into training and validation set only once, and if this were our experiment, then we wouldn't really know what to do. So, which is why this validation set approach is not really very good. So at least doing it once is not very good. So what we see here is that, well, to be honest, this first observation we have not seen it here because I did not report the training error. Right? So, but we saw it in the previous chunk of the lecture. So the training error can drastically underestimate the test error. So usually test error is higher than the training error, and sometimes by a lot. So, and if it is higher by a lot, then this is called overfitting. So this means that when we train our model, it tries to fit random noise rather than true pattern in the data. So, and if we do not have a lot of data, this validation set error can be highly variable, right? So which is why it's not really a robust method to estimate. So one thing that we do not clearly see on these graphs, but it should really be obvious if you think a little bit about it, is the fact that this validation set approach is going to overestimate the true test error. So why is that? So if we only have, say, if we do not have a lot of observations, like in this auto data set, so the total number of observations is about 400, right? So now, if we split these observations into 200 for training and 200 for validation, then it means that our sort of pseudo training set, in some sense, that we use to validate our model, it is only trained on a much smaller sample, and instead of 400 observations, we are using, well, just half of that size, just 200. So which means that any model that is trained on this sample is going to be just worse, right? So that is not a good model. Because generally speaking, the more data we use to train our models, the more accurate it is going to be. And of course, if we have, I don't know, like millions of observations, then it's probably not a big deal if we use, I don't know, 1 million or 2 million. But if the choice is between 200 and 400, then it may be a big deal. So which is why if we do this method by just splitting all available data into half-half, then we're going to overestimate the test error. Okay, so that's the end of the second part. So please do this quiz.